And I will explain to you how you can use this photograph to do something else. As skin diseases, they are also physical deformity in bottlenose dolphins and other species as well. Now, skin diseases using photo identification, skin disease studies using photo ID have been quite absent, at least until 1992, when Thompson and Hammond started a photo ID study to determine skin lesion and physical deformities on bottlenose dolphin of Scotland. From that time, and especially in the last years, we have a growing number of studies on skin diseases and physical deformity. And also, many researchers worldwide have started to make some correlation between the presence of these skin diseases and environmental parameters as well as contaminants. Now, skin disease data that comes from capture-release assessment project are quite good because you can see the entire body of the animals. You can also take a biopsy. But PhotoD offers a very good non-invasive approach to look at these skin diseases. You can do that when you're still in the field. And both of them together offer you a way to explore the history of these diseases and their occurrence in a population, and also monitor and track future diseases or new emerging diseases. So, what are the causes? So we can have fungal, viral, bacterial infection. They can be due to vitamin deficiency, diatom growth, or reaction to parasites. I'm not going too much in detail here because I don't have too much time. They seem to vary with the age and gender of the animals, and they seem to depend a lot from water temperature and salinity. Now, seems also the UV radiation are also involved. But anthropogenic factors also seems that they have correlation with the presence of the skin lesion on this animal. For instance, mercury, PCB, and DDT seems to have an effect on decreasing the immune system of these animals, and often they open the way to viruses like pox viruses and so on. Here is an example where high water temperature and low salinity, in addition of contaminants like organochlorine compounds, area where you have ballast water introduction and high cost of development, can create this type of diseases. This is called logomycosis or lacasiosis. It's a fungal chronic disease. This picture comes from the East Coast. The interesting thing with this disease that is found in human and 3 different species of dolphins is was observed for the first time in South America, and now we observe it for a few years now in the East Coast. So this is a disease that is expanding to other areas that we should pay particular attention. We have infectious diseases that can harmfully impact the population, increasing their mortality, like pox viruses, morbilloviruses, or affecting the reproduction, for instance, with bacteria like the Brucella. We also have non-infectious lesions. They can have a negative impact on reproduction. They can impair the feeding ability of the animals, and at times they can cause death. The interesting thing for the California bottlenose dolphins is the infectious diseases like red bacteria, like morbilloviruses, and the pox viruses can be a high epidemiological risk for this population. These animals move along shore, they come in contact with each other, they live in fusion society, so they come a lot in contact with each other. So we should be very careful of what's going on in the next year with these animals here. Bottlenose dolphins are a very good sentinel of the status of our environment. They move, the coastal population move really close to our shore. They are exposed to contaminants, and they are a very good indicator of these diseases and also emerging diseases that can have some impact also for human health. And as I mentioned, there are different, we can get epidemiological information from in different ways, mostly from capture release project, having biopsy. But again, PhotoD is a very good way for all of you that do photo identification to go out and collect pictures on this type of skin lesion that we can see. You can get all kinds of information. You can calculate and look at the prevalence and extent of the skin lesion, look at their occurrence and seasonality. You can look at the progression of these diseases, try to better understand what the anthropogenic factors are involved, environmental factors, and most than everything else, monitor these current diseases and if we have the emergence of new diseases. And here I just want to give you an example, actually 3 examples of how we do this. And the reason why I give you an example for my study in Santa Monica Bay, a collaborative study in the East Coast, another study in Northern California, is also to show you that we need to standardize protocols in the future, and we need more collaboration to better understand what's going on with this skin lesion that we observe out in the field. So even for skin diseases, you need high quality images. I'm not going into detail to tell you what a good quality image is because you will discuss this later on. But the animals needs to be, the fin of the animals needs to be visible, and at least the upper part of the body needs to be visible. So if you are now able in one shot to get both of them together, you want to have a close-up shot of the dorsal fin and then another shot where you can have also the upper part of the body. So you go through your matching, you get the best distinct photo-identified individuals, and these are the images that I use to look at prevalence and extent of skin lesion on these animals. In my study, I use ACDC for catalog and also for comparison of fin using also Adobe Photoshop. And Rich mentioned before all the things that you can do with Adobe Photoshop. In case of skin disease, it's very useful because you can enlarge the image. And I would suggest you to take raw images so you can use this image just to get a really good view of what's going on. But you can also alter image. For instance, in this case of the lobomycosis, if you change the contrast, you can observe better the extent of the lesion on the dorsal fin. I divide the skin lesion in different categories. This was based, my work was based a little bit on Wilson work and with some changes based on what I observed in my study here in Santa Monica. And I also look at physical deformity. I categorize them, and I also look at things like lordosis, different things that this animal show, especially from looking at my video as well. And then I calculate the prevalence, so the proportion of photo-identified individual that exhibit this skin lesion, both on the dorsal fin and on the body and the dorsal fin. Then I look at the extent coverage of this skin lesion on the dorsal fin and the dorsal fin of the body of the animal. So I look at the percentage of each individual epidermis that was covered by this lesion. And I divide in 3 different categories, low, medium, and high. So this is a different classification, and for the East Coast, as you can see here, they have more categories than the one that I had. I have about 6, and here a lot more, because here they have disease on the East Coast that I didn't observe in Santa Monica Bay, for instance, the lobomycosis and so on. They also have a high number of tattoo lesions, also called TSD. And these tattoo lesions are particularly interesting in the last years because they seems to be related to high presence of contaminants and are found often in coastal animals. And the picture on the left to show you a tattoo lesion in a young individual that was gone bad. So the East Coast, here you can see all the classification with the description of these very skin lesion that you observe out of the field. Again, there are a lot more of the one that I examined. The interesting thing is that if we look at the pathogens involved in the skin lesion, you see that, for instance, pox viruses, the pox viruses are found in tattoo lesions, spotted lesion, and dark fringe lesion. So we need, in the future, all the people that work on skin lesion kind of need to make more correlation between how a lesion looks like and what's the pathogen involved, and maybe all agree to for a reclassification of this skin lesion. This is another example. This picture was taken in Monterey, Northern California by Mark Cotter. This is interesting because we are still talking about California. So we have the orange film, for instance, the orange coloration that you see on dolphins was observed a lot more often in Northern California than in my study area in Santa Monica Bay. And it seems to be related to water temperature. They also give different name here, different from the East Coast and different from mine, to the tattoo lesion, or other people call ring lesion when they are still in the early stage, because they observe a lot of this pox-like ring or irregular lesion. Again, I observe a lot less in my study area. We are comparing this data and try to understand what's going on right now with these lesions. Here is a closer look of how these lesions look, and this makes you understand how difficult is this classification. For instance, you see pale lesions that look a little bit different from each other. Many times it seems to be the precursor of other lesions, or maybe a lesion that is correcting itself over time. Even tattoo, they can look slightly different. And that's why one of the problems that we give different name to different lesions. So, in conclusion, monitoring these diseases on bottlenose dolphins offer a very useful tool to track the current and future emerging pathogens on these animals. And photo identification offers a perfect system to do this in the field. But we need to remember two things. One, that you don't have an accurate estimate, but you have a minimum estimate of the skin diseases, because you can observe the entire body of the animal. And the second thing is, again, that we need more collaboration and standardized protocol to better understand the skin lesion in the future that can have an impact on the entire population of this animal and implication for human health as well. Thank you.